Hello. Today we want to talk about languages. Programming languages are designed for simplicity and expressiveness by humans. That is, your programming language, Java in this course, is designed to be something that you can speak and read easily. And that allows you to translate your thought into a programming language without a lot of strangeness. Now, no machine understands any of this. What we write in Java, machine does not understand at all. It's completely foreign language to the machine. But there are programs we use that convert from our symbolic human languages into machine instructions. Those are typically interpreters and compilers, and we will use one of those. Machine languages are composed of just bits and bytes, binary numbers, ones and zeros. They encode or describe to the CPU the operation to do. A certain number is means, for example, add. A different number would be multiply. The CPU conceptually is just saying do instruction type 1, do instruction type 54, do instruction type 31, and just step by step they do it. And whatever that number means, that's what the CPU does. That's how it processes the data. Some machine languages are simple. They don't have very many instructions, and the numbers given to those are fairly straightforward. And with some use, a human could use them, but still they're rather difficult because they're just strictly numbers. And we don't think that way as easily as a machine does. Each machine language is supported only by a CPU type or a family of CPUs. For example, the Intel ones. Any program that runs on one Intel runs on many other Intel type CPUs. A program designed for an Intel CPU would not run on an ARM or an Atmel type, and Atmel was in programming boards like Arduinos and whatnot. They don't understand each other's languages. So, like somebody who speaks a human language that you don't understand, neither do these machines understand each other's languages. These are, as I have said, fairly hard for humans to understand and get a grip on. But thankfully, we don't have to. Now, one step higher is assembly language. What that does is it encodes machine instructions to a symbolic mnemonic. So rather than saying, for example, instruction 35, we say add, subtract, multiply, shift, something like that. That's a lot easier for us to remember because when we're thinking and solving the problem, we say, I need to add two numbers. Oh, the instruction would be add. Makes sense. For example, 35 doesn't make a lot of sense, but an assembler would convert that add to the number 35, for example. And that's done, fairly straightforwardly. One of the greatest advances in programming occurred when mathematicians no longer had to use machine language but used assembly language. That opened it up for many other people that weren't as adept perhaps at math and were able to do far better. But assembly language, like machine language, is really dependent upon the CPU. You have to understand how the CPU works. Even though assembly language is symbolic and easier to do, still you must know the details of how a CPU is going to manipulate data. Otherwise, you would have no clue how to program it. Yes, and most people do find that very, very tedious. Don't worry about it. We won't do that one. Now, high-level languages, Java is included in this group. These are languages that are much more closely aligned to what humans speak, as I said before. Generally, they have a simple sentence structure, one instruction line at a time, typically. May be complicated, for example, a complex computation, but basically it's grouped together and it means about what an English sentence would mean. It describes one thing. We would just make multiple sentences to do a sequence or solve an algorithmic problem. Now, I say that they're imperative statements because they are telling or instructing the machine what to do. We're not asking it questions so much as we're telling it what to do. We're not describing something so much as we're just simply saying, do this. And most Java statements end in a semicolon instead of a period, like English and many other languages. A lot of programming languages end the sentence in a semicolon, so that will be a difference you'll have to learn. The program lines and words and instructions you write are stored in a file. That's just a file out on a disk drive somewhere. And that's called a source file. The source meaning where it begins or where it comes from. And this file is used in the beginning of this translation process, converting your programming statements into machine language. And the source file is really a translation of your thought into a programming language. So there are many levels here of translation. A compiler is what we will use to translate the source file or the source code, the programming code in the file. That will be translated by the compiler into special machine instructions that the Java virtual machine knows how to run. And the output of that is an executable file that ends in the extension .class. So that's the output of it. And if you ever come across a .class file and want to look at it, do so. Most of it won't make any sense.